Buren has to.
Cool. Right. So yeah, should we start?
Yes, go ahead.
All right. So great. So GraphQL is like one of the most interesting ideas in distributed systems in the past few years. It's like a query language, but for APIs, and it's very intuitive and easy for the clients to implement. Yeah, servers are a different story, but at least for the clients, it's actually very easy to implement. And as you know, I'm Vagmi. I am the CTO of Serin Technologies, and I head a consulting division called Tarka Labs. So we are pretty much everywhere, but here we are based off in Planet Hatch. So I've been doing this for about 20 years. People have been paying me money to write software, and thanks for having me on board. So before we jump on to GraphQL, I wanted to talk about like the history of APIs. Like we have been building distributed systems for a really long time, like ever since 1970s when computers were like size of big rooms, and then like exchange some boring documents like purchase orders and all that. We use something called as electronic data interchange, right? It's basically like text files or like structured like binary files with text in them, and they use like modems, but then they switch to FTP or SFTP and things like that. And around 19, and mostly they were all like mainframe systems and all that, and C++ was there. It was using some of the stuff, but things didn't actually kind of change until like Unix machines came into the picture, right? And TCP IP was kind of established, internet protocols were set up, and once internet came in and we started mixing computers together, and businesses started adopting it at scale. So that's when this whole distributed system games really started. Uh, the one of the first things that came up for general consumption was RMI, or remote method invocation, and RMI was like in old Java, like the slow Java. I think Java 2 was the first target, I suppose, that had like when I say Java 2, it's like Java 1.2 was then called Java 2 SE. They had really confusing naming versioning conventions actually. And that was the first one to actually have this. So it implemented a remote API, and they specified the transport, which is TCP IP, and they also specified the serialization format. It was called like the Java's object format, and that kind of worked well, but it was just for Java. And since this was Java of 1997, it was really slow. It didn't even have like the JIT compiler at that point in time. So the code was compiled, but it was not like running and the native code. So most serious business applications were still written with C++, and the industry wanted to formalize kind of like a distributed programming model. Until then, they were still doing distributed communication, but there was no formalized model. So people would just use TCP sockets to talk to each other, and it was like a one-is-to-one communication. So, and then around the same time, industry basically looked at RMI, and this space was heating up, and they created something called as Corba, and it was like Common Object Request Broker Architecture. Don't ask me why I know it. I mean, it's one of like I just started getting into computing, and one of the first systems I actually worked with was C++ and Corba. And Corba was by this group called the Object Management Group, and anybody who used to work with it, like an object management group was like OMG, right? And there was like a healthy dose of expletives when they also mentioned Corba in this thing, right? And there were IBM, and there was Microsoft, and there was SAP, and all these companies wanted a piece of that, and they wanted to keep it agnostic of the operating system, the implementation language, the transport protocol, serialization format. They couldn't agree on any of it. So the only thing that they did right was an interface definition language called IDL. And the IDL was basically said, oh, these are the functions. This is what the input is going to be. This is what the output is going to be. So it was very similar to what RMI looked, but without the benefits of it all working together. And Microsoft at the same time created DCOM, which is like distributed COM, and they had a Microsoft Transaction Server to coordinate like these kind of messages that they were sending across these different machines, and how they communicated and all that. And again, Java at that time was trying to grow up and be taken seriously, and so they actually built J2EE and EJB and all those things. So these were basically like very dark days of distributed systems. And around 1998, Microsoft created XML RPC, the standard, which allowed XML messages to be sent over the wire. And so this actually again standardized on the serialization format as well as the transport protocol actually. So which made it very usable and very interactable. So that means that you could write an XML RPC server in .NET or Java or Python, and they could all communicate with each other actually. And the ideas in XML RPCs were pretty good that they then got adopted into SOAP, which is the Simple Object Access Protocol. Again, it used as a part of the IDL or the interface definition language. It had that also was expressed in XML, and they called it the Web Service Definition Language. And it kind of like Microsoft embraced web services and basically gave SOAP a huge push. And they were like, and so was like every other company, like SAP was doing that, and so on and so forth. And the software industry started moving away from like the component model of software to the service model of software. Like, in component model, the idea was that, oh, this is like a defined component and this component will talk to that component. There's this tight coupling, and that's what like people are talking about, the RMI interfaces and all that. So SOAP was probably the first thing where they started recognizing the service oriented nature of how these things can communicate, and recognize the fact that things could go down, and bring in resilience to the system, and so on and so forth. And I think SOAP was around like 2000, early 2000, 2004, 2005. SOAP was all the rage. There was a lot of like WS standards that were there. People were talking about, oh, how to add authentication on top of it. How do you do aggregation on top of it, and like all kinds of extensions to it. And it was crazy, and it was getting very difficult to actually write services. It was overly complex and all that. And while SOAP was ideally suited for, like typed programming languages, Java or C Sharp or whatever. But then like there was this newer crop of languages that were coming up, like Ruby and Python, and they had their own frameworks like Rails, Django, or TurboGears, and all those kind of things. And they basically were trying to move away from um, SOAP, and they were basically looking at just simple HTTP calls for communication. And around 2005, browsers also started getting more powerful, and they were able to run complicated JavaScript applications directly on the browser. We had actually, um, you know, Firefox was blazing its way through, a lot of research on JIT compilers that made JavaScript really fast on like modern browsers, right? And of course, the addition of number of cores, the CPU speed, and all those things, kind of like Moore's law basically helped in making browsers mainstream. And given that is the case, basically JSON was born as a data format, because people said, hey, if we can load a complex application on the browser, then make it long running kind of a browser, and then we can just get pieces of information from the server and the browser can handle it. And that's how JSON was born. And this whole REST JSON thing came into being, right? And in around 2000, actually Roy Fielding had written a paper called the representational state transfer. And we talked about like resources, URIs, actions, metadata about resources, like linked resources, or like possible actions you can take on that. And you also had representation metadata, like, okay, what is the format of it, what's the size of it, and all this. So he tied all that as HTTP, and he said that using the HTTP protocol, you should basically treat your application as a state machine or a stateful kind of like resources with states, and how you can go from one state to the other using actions and parameters and adopting HTTP. So while this was just a dissertation and a thesis for a long time, around 2005, the Rails world started playing around with it, and by 2007 they had like a first version of Rails 2 which supported REST as a default paradigm. although it didn't support like all of the rest, it basically said, oh, these are the endpoints. Our active record models are now resources. Some of the basic actions like create, retrieve, and update, delete are basically standard HTTP actions on that. If you want more actions, you can then map them onto it. But then it did not formalize like a discovery of API. It did not formalize how the API will be documented, or it did. In short, it didn't talk about like an ideal or a interface to it. So the contract was not set up. So that basically around that time, people were just getting used to this distributed applications and all that, and people are writing a lot of REST-ish services because they were not like pure REST services. They didn't take into account how these systems could discover each other. Like for example, if I was talking to say the GitHub API at that point in time, I had no clue what actions GitHub server actually supported. That means that there were a lot of these libraries that were used to connect to GitHub, and each one basically had to play catch up with every time GitHub changed its APIs and interfaces and so on and so forth. And that was getting very tiring, very difficult to follow. And around 2015, Facebook released GraphQL, and around the same time, I think in 2012, I was working with Thoughtworks, and we were building a microservices based application, and we had a Java service, we had a Rails service, and we had yet another Node service which used to consume these two and do this. And there was just a lot of repetition. So you had these objects in Java that then were consumed in Rails, and the Node.js app was basically trying to consume all of them and all that. And we felt that I was writing code three times. I was writing once in Java, I was writing it once in Ruby, and I was also repeating myself in Node.js. And all Node.js was doing was like, making calls here and making calls there and trying to map these two things. And all these three were built by members in the same team, right? I mean, we used to sit right next to each other, and we couldn't keep up with each other's APIs across these versions, and it was very frustrating. And we were and it was inevitable, right? I mean, the industry was facing the pain at that point in time that someone had to build something like GraphQL, and it just happened to be Facebook. Netflix also had a similar model. They had something called as Falcor, but it wasn't quite as popular. It was simpler to understand, but it was not quite as powerful as GraphQL. And I think GraphQL was also very well documented. When they released GraphQL, they released it with a very complete spec. They talked a lot about it. It was marketed extremely well in their conferences because they already had a React conference going at that point in time. So they were able to introduce GraphQL very well. So, and around the same time, Google released gRPC, and they were like two diametric approaches to APIs, actually, right? So GraphQL was all about, oh, you have this declarative graph of data, and it was coming from Facebook's social network, right? So they had to use these social network analogies like, oh, this is a graph, and these are the nodes, and these are the edges, and this is how you go from a graph to an edge, and this is how you discover, and so on and so forth. Google was, again, like in the typical sense, they were, oh, this is gRPC. This is basically RPC, but G is because they are Google, and they're using a very efficient binary format called protobuf. And on the server and from service to service communication, they just said we'll just use HTTP2 because we have long-lived sessions, and it's a binary protocol, and we can do streaming and so on and so forth. So these are the two technologies that came up, and they're still like fighting with each other. I think every project that we build right now, we have a discussion. Oh, should we build the service using gRPC, or should we do it with GraphQL, or should we just do a REST implementation or a REST-ish implementation, and so on and so forth. So that's an argument that happens pretty much like every time you're building a new service these days. But frankly, I really like GraphQL, and I use GraphQL anytime I want to talk to a server from a browser, right, or a mobile client or things like that. But when I have two services talking to each other, and both of them are on the backend, they're not exposed to the browser, then I tend to reach for gRPC or a similar kind of like an RPC kind of server. So that's that. Any questions? I'd be happy to take them. Okay. If there isn't, then let's move forward. So GraphQL essentially supports three types of operations. So you have queries, which is used to read data, and you can basically, ask for just the data that you need. You don't have to overfetch data or underfetch data. So if you're writing a mobile component and it only needs like 2 fields, right, you just have to get those 2. Or if you are on a desktop and the same component requires multiple fields, then you can get what you need. So you can exactly request for the fields that you want, and the server must give it to you. Mutations are basically RPC calls. They are similar to RPC calls, where you just send some data to make some change, and then the server basically then responds with some output on that. So it's not quite CQRS, where I mean, it's CQRS stands for like command query responsibility segregation. So it's not quite that, but it's kind of tending towards that, right? So where because in a typical CQRS pattern, you shouldn't rely on the output that a command gives you. You should just, issue a command and then, subscribe to whatever changes that happens from there. But in this particular case, once you issue a command, it also returns a result back, which can then be used to update the client state. Um, and then there are subscriptions. So subscriptions are very interesting because if there is some other user who's making changes to the system, you can observe those changes and then you can update the state on the UI. So GraphQL is only a specification. It doesn't talk about how you should go about implementing it. Like, it doesn't say that you have to use HTTP or you have to use WebSockets or whatever, but almost everybody uses HTTP and WebSockets, right? So like, for example, the first 2, query and mutation, are probably going to happen through one single endpoint, which will be post/GraphQL. Although some frameworks are trying to change that, like for example, Apollo is introducing like cached queries and all those kind of things. And subscriptions would most likely happen through WebSockets. So, but that may change with maybe server push events or things like that when HTTP2 and other things are supported in the in sort of like load balancers and things like that going forward. So let's talk about clients, right? I mean, so as I said, GraphQL is basically a specification, so it doesn't ship any clients or servers. So its community essentially comes up with its own kind of like ways of interacting with GraphQL. So as far as GraphQL clients go, there are essentially like 3 big ones: Apollo, URQL, and Relay. And Apollo is by far the most popular. I mean, it supports writing both clients and servers. It's kind of framework agnostic. When I say framework agnostic, you can use Apollo with React or Angular or Svelte, whatever you are building, or Vue, right? You can use it with any of the JavaScript frameworks. URQL is also very similar to Apollo. It also works with any JS framework. In fact, it was specifically built to be framework agnostic, and Apollo kind of like added that later at a later point in time. And it's significantly lighter than Apollo, so it it focuses on like code bundle size and so on and so forth. And URQL is a fairly newer project, and it's kind of gaining traction in the community. And then there is Relay. Now, Relay works only with React, because Relay is also from Facebook, and Relay also requires the server, GraphQL server, to follow a certain specification. Most good GraphQL implementations actually have this. Like for example, the GitHub GraphQL API or the Shopify GraphQL API already support Relay, but say some of the custom GraphQL servers that you may interact with may not support Relay, in which case you cannot use Relay as the client. And Relay has a particular view of how GraphQL has to work, right? I mean, it talks about, all these nodes should be globally identifiable. You should be able to paginate on whenever you have a collection, you must be able to paginate. You must be able to get to a cursor and do these things. While uh, all of them are very sensible defaults, very sensible expectations on what the server should support, and all that, but not all servers support that. But thankfully in CivicTech, the meal planner repo that we're using uses PostGraphile as the backend, and that implements Relay, and it actually makes it easier to work with GraphQL that way. And Relay recently has also gone through a big refresh. So they have tried to extricate themselves from React. So earlier they had all these higher order components and so on and so forth. Now they're using hooks, but they're also the Relay runtime library is technically framework agnostic. So only if you're using the relay hooks, you're tied with React, but you can use relay with other frameworks as well. But it's fairly new. It's only a couple of months old and all that. And relay has also been rewriting its underlying compiler and all that with Rust actually, and it's been getting a huge performance boost in that process. And in my opinion, almost all these frameworks are converging to like a common set of use cases. And I think they'll all pretty much be the same, given like 6-7 months down the road. If you look at any of these three frameworks, they'll probably support all the functionalities that each other support. They're heavily drawing from each other and implementing those things. Like for example, Relay is also implementing cached queries that Apollo supports. There is a fork of Relay that actually supports file upload standard, Apollo file upload standard, or the multi-part URI. So all this is coming along, and it should just work in a few more months. On GraphQL servers, though, it's like a completely different story. While the client is more or less choices are clear, on servers it's like the wild wild west. You can pretty much build GraphQL servers with anything, because it's just a spec. It gives you like, oh, you should respond to a GraphQL endpoint with a given query with a given JSON document, right? That's about it. So that means that you can, mostly people use Apollo because they were the earliest in the field. But then Apollo's initial examples were so bad that people actually called GraphQL like an N+1 as a service, right? Most developers who looked at server backend developers who looked at GraphQL were horrified by how they can support a format where a client can ask for any shape and we are supposed to respond in a kind of like a performant manner. So as a backend developer, when I looked at GraphQL, I was like, oh man, I have no idea how I'm going to support that. But I think over the years, at least ever since like the past 3-4 years, I think the patterns are emerging as to how to support these things well. Facebook released something like Data Loader, which said, okay, how do you avoid N+1 on like batching transactions? And then people started looking at look ahead kind of transactions where they said, oh, if you're getting a field on GraphQL and it is asking for some subfields, maybe you can optimize the query by doing this. So essentially, when people are writing GraphQL servers, they are writing query translators, right? They are converting the query that they're getting from the client to the queries that other backends that they support. So sometimes it could be SQL Server, sometimes it could be flat files, it could be data on S3, it could be some other API, but it is the choice that the server has to make sure that it translates all that into the most efficient form. And apart from like Apollo and other things and language level libraries, like I have built GraphQL servers in Rails, and I've also built GraphQL servers in Go. But in addition to that, you also have like database as a GraphQL service adapters. Like for example, we are using PostgreSQL as a part of Civic Tech Fredericton, in Mean Planner. But there's also AWS AppSync, which does that there, and then there's also Hasura that does that, and there's also a bunch of other like GraphQLize is another thing that I know one of my ex-colleagues in ThoughtWorks has written. It's written in Java, and so on and so forth. So there are a bunch of things that support the GraphQL API, and yeah, but it's still is a lot that's happening in the GraphQL server space. So we'll have to see how that plays out. And so let's look at some code actually as to what GraphQL actually supports. So GraphQL actually supports like int, float, string, boolean, ID, and date as the standard types. So although date is not technically a part of the GraphQL spec, date is often added, but I've never seen anyone who has not added date as a scalar. But date is kind of like added as a standard thing that most GraphQL servers support, but it's not a part of the spec. ID is also a special type. ID is mostly serialized to a string, but it is not meant to be like human readable. It's supposed to be like a unique identifier. They put it out there, but then yeah, that is also a scalar. So, but pretty much everything else means what it is. It's like just a number and a float, and these are all like JavaScript you know, types. And so they've tried to make it as compatible with JSON and serialization as possible. It also supports enums. Um, Again, on the client, enums are basically serialized to strings. And on the servers, I mean, you're free to choose how, I mean, like for example, in Go, Go enums are essentially consts with an iota. Um, Rust has really great enum support, but you cannot actually implement the kind of enum that Rust supports in you know, this kind of language. So essentially, people still just use this as a string, right? Const string, and say just Sunday, Monday, Tuesday, it'll all be serialized to string, and you use it as such. Um, and then once you have that, you can then create these types. Like for example, you could say type user, and you'd say ID is ID, name is string, and you know, you speak a bunch of languages. So here, and if you see, there are some fields that have the bang mark on them. So an exclamation mark basically means that this is a required field, and you know, that's where it is. And you can also declare an interface on a type, and this doesn't mean that it's really a type. It just means that there are other types, like for example, post, that can implement node. And even when you say it implements node, you still have to say ID is ID, and you have to repeat whatever is in there inside the type that you are implementing actually. And pretty much everything else kind of like comes in place. And the best part about it is now, since you have the user type defined, you can have a field called author, and you know, that can point back to the user. Sorry about the indentation. I think something has gone wrong in the format. But I mean, basically author is of type user, and so it can expand on to user and all that. And again, as I said, you know, date time is not a scalar field, but then you can implement it, and it's up to the client and the server to decide how to negotiate. For example, you could say, hey, this is date time a is this thing, but you can serialize it as a string, and string in an RFC 222 format should be fine. Right? And then you can do that. So we'll look at some of the schemas that are defined, and then we'll see how that works actually. So so apart from these scalar types, enums, arrays, and these complex types, there's also another type called an input type actually. So input types are mostly used for mutations, and so the rule of input types is that whatever fields that input types have, just like your normal GraphQL types, they can you can have scalars or enums, but then if you want to have another type like in here, that also has to be an input. So the type of any of these fields cannot be like the standard output types that you can use in queries. And so, like for example, here I've created a mutation, type mutation. There's a bunch of other stuff in here, and then you have a create post, and we say input is of type create post input. So it needs to have like some mutation ID that you can pass in from the client, some title, some content, and after it has completed, it should create a create post payload that would then have the post, and then maybe, you know, just return the query object so that you can then take that post and then like you know, query, then have subsequent queries that you can do that. So you can do stuff like this actually. So let's look at some like live running servers. Maybe we'll use the meal planners GraphQL server that we have, and then, you know, go from there. So I'm just hoping that most of these work, but let's see. Um, so I'm going to kind of get some of these things out, but let's see. So the first time you launched, you know, meal planner on this, so you would see, you know, these kind of like outputs that are there. So this is one query that runs. This is called the introspection query that always runs. So what this does is that, so let me pretty print this. 225. Okay. So this is a query that PostgreSQL runs, which actually populates this query, the introspection query here, right? So on the Explorer. So the Explorer kind of gives you, so if you hit Explorer, right, you see all these things, right? This is what it actually displays, and that by itself is a GraphQL query. So each one of these GraphQL queries you can reflect on the server, and it will tell you all the type of the of what the server supports. And this seems quite nice. And in fact, most servers don't support this. Like if you look at any of the REST servers or things like that that are there, they'll have a documentation site which will say, oh, this is how you use the site, right? And to do this. With GraphQL, that's kind of built in, right? If you say the server supports GraphQL, that means that it will expose what is possible and what is not possible. And most likely you will also have good documentation on this. So let's look at some of these kind of things. So let's start by writing a query and then we'll go from there. So this is like a pretty complex query. So let's start writing simple queries. So let's start by getting all the people in the database. Okay, so what I'm going to do is I'm going to clear off these headers that are there. Okay, there are no headers, that's good. So I'm just going to say query, and I'm going to say people, because person kind of like becomes people. And then for each one of the people, so we get nodes, and then we basically say ID, row ID, full name, and yeah, we'll leave it at that actually. Yeah, let's also put in type, just so we know what is the type of the people's nodes that we are getting. So okay, so this basically it's not. So let me turn off explain. Right now, it's not getting me in any data because I am not authenticated to the server, right? So I do not have permission to read who all the people are, right? So it's not giving me the data. So it's not an error. It's just that it's a valid query, but it's just that I'm not allowed to get any data on it. So it basically doesn't give me this. So let me log in and then let me get all the data from there. So let me hopefully I have the password written down somewhere. Okay. So I'm going to write a mutation and I call login. It's called authenticate. And then I'm going to say it. Okay. I'm going to run this and then I'm going to show you what it has. So what I essentially did here, I mean, forget about how it works, but let's talk just about the JavaScript, the GraphQL part, portion of it. Now, if you notice how this data is being sent, let me pull up my network tab and I'm going to hit this login again. Okay, and exit jar. Interesting. So it didn't run the query again. Oh, because nothing changed. So mutation, it should run that. Oh, maybe it's not right. Just yeah, I was looking at the wrong. So let's hit login again. Okay. Oh, it says 2 requests gone. I'm filtering something. Oh yeah, I'm filtering something. Sorry, my bad. Yeah. So so let's look at how the query is being done actually. So the query we are actually calling. So this is the post endpoint that's going. So like it goes to localhost 4000 GraphQL, and it's going as a post call actually, right? And the payload that is being sent is basically the query that we've written here. The entire query is available. Like it says query all users, and it says mutation login, blah, blah. It sends the whole query in it, and it also has an operation name that's there. And this is basically sent to the server, and the server basically knows what to do with this whole thing, right? And I also have variables which I don't need for this example. So let me get rid of this. So even without these variables, it should work. Yeah, and So there are no variables. It just says it's null and it comes there. And the preview basically is just basically data authentication JWT token. And this is just JSON actually, right? So this is just normal JSON. And it says data is the key, authentication again has the key in it because that's the name of the mutation that we had. And that has a key and a value. So this is just normal HTTP call, normal JSON request, nothing crazy happening here. Right? It's actually fairly straightforward. Now let's look at the authenticate the mutation and see how it's defined actually. So for that, I'm going to, I mean, the schema here is nice because it's kind of generated from PostgreSQL, and many of these comments from our PostgreSQL functions are basically gotten in there. But I want to see this from the schema GraphQL's perspective. Now, since we use PostgreSQL, we can actually export the schema, and I'm going to load the schema up on thing. So and feel free to interrupt me at any point in time. Any questions, I'd be happy to answer them. This is the wrong. So schema GraphQL. This. Okay. So as I said, there is this type query, and then there is, okay, let me write this, and then there's this, there'll be a type mutation. So this type mutation, and within the type mutation, you'll have the authenticate mutation actually here. So let's look at the authenticate mutation. Yeah, authenticate mutation. Now, so this is how this is using the GraphQL language actually, right? Because this is how we define the schema. And here, if you see, we basically have a mutation. Within the mutation, we are calling authenticate. This is a field in the mutation, and this has arguments, right? So it has a one argument of type input, and that is authenticate input, and we must provide that. Okay, so let's look at what authenticate input has. So it has an input, authenticate input. We have a scalar called JWT token. So we say that this is a scalar. Don't worry about how it's implemented. This is how it is implemented actually. Right? And then we have the authenticate input. And in authenticate input, we have client mutation ID, but we are not passing anything. So we are not into it. And it is string. It's not string bang. It is string. So it can be null. Username can also be null, password can also be null, but we are passing these two, and it's there. And this is the object that we pass in to authenticate. So let's go back to our browser and see how. So this is authenticate, and this is the input that we're passing in, and this has user email and password. So let me format this a little bit so that it's a little easier on this. So this is the input, and this is there. Now, authenticate basically returns an authenticate payload. Okay, so let's look at what that type is. So this returns an authenticate payload. So the authenticate payload has a client mutation ID, and then it has a JWT token, and it also has this query, which is very interesting because this is a root field, and you can basically put any query inside it. Okay, so let's see how that works. So here there's this JWT token, and we say that this JWT token is the scalar, right? So we say this is a scalar, and when we say this is a scalar, it basically gets serialized to a string, but it's a different type. It's not really a string, but it gets serialized to a string actually. And this is how the alias types are kind of handled. And even though it has some meaning on the server, on the client, they're basically strings actually. It could have a different meaning depending on how GraphQL is implemented. Say maybe on the mobile, on Android, maybe there could be a class which gets mapped onto it and it knows how to serialize it back from the string. But essentially on the wire, it's a string. On JavaScript, it's a string. And so it just gets treated as such by declaring a scalar here. So That's that. And we have got the JWT token. So now let's stick our JWT token into the headers, actually. Yes. And now let's click on all users, right? Now we get a bunch of users. So now let's look back at our console to find out how this call succeeded and what changed here. So it's still post to GraphQL. And then in request headers, now we have the authorization header. Earlier in the previous one, there was no authorization header here, but apart from those two, these two calls are pretty much the same actually, right? So there's this authorization header that gets added here. The payload is still the same. So it's just that this time we pass in the query and we say the operation name is all users. This is the operation that we want to run. And that has this query, like people, nodes, ID, row ID, full name and type. Right? So that's the query we are trying to run. And so the preview basically gives us the same kind of JSON where it has people, nodes, ID, blah, 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 all those things. With me so far? Any questions at all? Sorry, if you're raising hands or something, I might not know. But yeah, so let me continue actually. So now that we have our query and our mutation, let's see what else we can do with this actually. Um, so let's try to extract some portion of this people out. So like, for example, let's say I want to have a list of meal plans, and let me get meal plans. And I'm going to do um, nodes, name, then I'm going to say person, I'm going to say ID, row ID, full name. Right. So I'm going to basically get a list of meal plans and I want to show this. Now, if you see this portion of the query, like ID, row ID, full name and type name, is kind of repeated in both these queries actually. So what I can do is if I have pieces of code that I have to reuse, I can declare them as a fragment actually. As a fragment, and I can call it, say, person details on person, and I can basically have this here, person detail on person, and I said, and here I can simply reuse that query, and I call them person details. So what this allows me to do is kind of let me reuse pieces of GraphQL code, across different queries. So both meal plans and all users will use this fragment and they'll use them here. Actually, so, and this is heavily used in Relay because what it does is that if you have a UI component and the UI component requires certain data, you basically segment that into a separate component, and you basically only use that here. And that's extremely powerful because now the component's data that it needs is kind of local to that component. And so you can compose these fragments onto a larger query and you can send that to the backend. So that also reduces the number of fetches that you're making to the backend. So, this was essentially built for like, mobile clients and things like that, where your latency is actually very high. Your throughput may be very good because you may be on, a 3G connection, which has a good bandwidth, but your latency is probably very high. So unless you're on 4G or 5G or something like that, then, or say on a local Wi-Fi or a wired network, then it's a different thing altogether. So that's that. So what else does GraphQL give? So it also has directives. Now, directives are kind of like it depends what the client needs and what the server needs. Now, directives, basically GraphQL only ships at two directives, which is basically include and skip. So the way it works is that, say, for example, um, I'm on a mobile view and I don't want to show person details if I'm on mobile. So let's do that. So here, um, uh, if I want to skip, um, or let me do variables first, and then I'll come to this actually. So say for example, I have a query which has where I'm going to get a meal plan, and this is like the meal plan summary that I want. So I'll say meal plan. Um, uh, and I can pass in arguments to this. So I want row ID 1. So the reason I'm doing row ID as string 1 is that row ID actually is a big int. And just like how we have that, it's a scalar. So if you let me open up this begin. So GraphQL itself doesn't give begin. So we say basically this is a scalar. So I'm just trying to find that definition. Yeah, scalar begint. So since we say scalar begint, it's essentially a string that gets serialized, and on the server it will be cast back to a string, and but on JavaScript and this thing it will still stay as I mean sorry in on the backend it will be cast to a begin from the string, but on the client it will still be a string. So we got to use this as a string, and we're going to get, say, name, uh, description, meal plan entries, nodes, meal, name, right? And then we'll also show what day it is and what category it is. Right? So this is typically how you query for a meal plan. So let's do that. So is that. But the point is, you don't want to keep passing in this as a hard-coded query. You want the query to be fairly common, and you want to pass this in as a variable. So you basically you pass in a variable to this. So let's say dollar meal plan ID is actually a begin, and you say this is actually the meal plan ID. And in the query variables, you can basically say meal plan ID is 1. And if you run this, so it'll have the exact same output, but then you would have variables being passed in. So let me show you that. So this is the last thing. So if you look at the headers, again, the authorization request header is there. And on the payload, you have the query, which is basically having everything. We have the meal plan, which is the operation name. And then we also have the variable, and it says meal plan ID is 1. And so this basically gets substituted. So this way, you can have this query cached. So this is like this big query that you're sending in. Um, and so if you know that this is the query that you're sending in, and this is the variable name that you're sending in, and if these haven't changed, you can actually cache this result and then send it back to the client. So this gives nice it makes it easy to add performance to, or you can use it for performance considerations and all that. And that's what Apollo is doing with its cached queries, is that they're taking this and they're caching it along with the variables, and then say, oh, as long as we get the same request back, then you don't even have to parse this query, just serve it back from the cache on the server side. So that's variables. And we can also do directives. Say, for example, um, you are building like a, like a detailed view, like a list detailed kind of view, and you say you're looking at, say, a meal object. Okay, so let's say I want. I know if we have meals on the server, but let me just query all of them, and then I'll show you how it works. Nodes. I'll just get the name for now, just to find out if there are meals on it. And I'll probably get the row ID as well. Yeah, we have some 4 meals on it. So let's just get the first one, row ID 1, and I'll say name, description. Oh, I don't need the nodes here, so and we'll see we have the photo URL, video URL, um, is there a preparation or something like that? Yeah, method is there, and then we also have the tips. Yeah, bunch of stuff like this, right? So let me prettify this, and let me run the meals query again. So if you see, it has all these kind of things. But say, for example, you're writing a component that that shows a expanded view. So you have a summary which just shows the name, and then we have the expanded view that also shows the other components, right? How do we do that? So what we can do is we can write a fragment that will say extended. So we'll say fragment meal on meal, and we'll chuck all these into there, and let's modify this. Sorry. And then we'll say dot 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 extended meal if, and then you can say include if extended, and we'll get this as a query. Um, I mean, if it's a problem, it's going to tell me. Oh, include if. I'm missing something. Just give me one second. Yeah, I think this is the way you do it. So you just say include if extended, and so if extended is set, then it's going to include it. Otherwise, it's not. So let's do pass in. We'll also pass the meal ID as a variable. Actually, that makes more sense. Uh, and then pass in meal ID as well as a variable. So that way we could say meal ID is this, and extend is false. So let's run this query and see what comes up. Oops, variable extended is okay, used in position, and okay, this needs to be Boolean pan. I'm sorry. So let's do that again. So meals. So yeah, if extended is false, we just get the row ID and the name, and if extended is true, we would get the whole thing. Right. So this way we can actually have this thing in there. And say, for example, if you want it to be name en, you can also call it name, and it should alias it for us. Sorry, I think it should be alias colon. So this way we can also rename components in here. So this is not particularly useful because, um, and I will also not recommend that, but it is possible in case if you want to, I mean, if you added a new field and you want to make it look as if it's an old field and you don't want to like do this, you can also alias fields in GraphQL, but yeah, it's not my favorite feature. I'll probably not do that. So one thing I wanted to show was errors. So we saw parse errors, but you can also have runtime errors that are there. So let's maybe do a runtime error and see how that comes up actually. With me so far, any questions? Am I audible?
What is a scalar?
Yeah, scalar is basically data types that are very simple, like string, int, and floats, um, you know that kind of stuff. So it's not like a complex data type, it's just one value in it. So it's not made up of different parts, so that's called a scalar. So right, so let's try triggering an error and then let's see how that works. So we need to make sure, um, yeah, maybe we try to give a wrong username password. I don't know if that would, yeah, that triggers an error. So, I mean, it's not quite the error that I was looking for, but it's there. So, when you have an error, a mutation on a query, the only thing it expects you to say is have an errors key in the body actually. So as long as there is an errors key, which is an array of errors, and it has a message on it, I think that those are the only two things GraphQL mandates. Everything else is up to the server side framework to provide, and for the client side framework to then do what it needs to do. Like for here in this case, it's giving a pretty detailed stack trace. So depending on your framework that you're using, it would change. This would change, but you would definitely get a key called errors, and then you will have for each one of these keys, they'll have a message in them. So that's errors. And that's pretty much what there is to GraphQL from a query language or from this perspective, right? Everything else is essentially up to the client libraries and the server libraries that are to then work with, right? So yeah, that's pretty much all I had to show.
What is an edge?
I'm sorry, what is an edge? Oh, cool, we missed that actually. So yeah, so here, so let's do it in mean plans. Um, so we have edges and then we have nodes. Now, uh, so if you so so when we talk about graphs, so you have nodes which are like say the objects that are there, and then there are connection to the objects. So let's run this query and see how what happens. So we have edges, and these edges basically have a cursor in them, and this cursor is essentially saying how I reach this particular object and what is the position it is in. So as you can see, this is like a base 64 encoded string. Let's decode this to find out what this gives. Oops. Right. So it basically says that this edge is basically the primary key of one for this node, and that is essentially what this is. So the this basically contains the path to get to this node. But you can also do this. So you'll have different edges, and each one of these edges will have a cursor. So that's the line joining two nodes in a graph. Um, and another thing, so I wanted to talk about relay. I mean, this is not strictly GraphQL, but this is relay. Is that when you have these meal plans, so these conditions are there. So one of the conditions it has is like, for example, after, so let's look at meal plans. And if you say this is of type connection, and this type connection basically has these nodes, these edges, the page info and the total count. And this page info object is a part of like the relay specification. So it basically says, okay, how these edges can be paginated, how you can, how you can get the first few or the last few and so on and so forth. So all this is pretty straightforward with relay. You get it for free. So like, for example, you can just get the first, I think there's just one. So maybe we can do this for meals. And then we can do this here. Prettify this. Oops. Meal ID is never used. Yeah, that's fine. We remove that. Yeah, I think this should have a lot of meals. There are 3. Yeah, maybe we'll paginate it to the first 2, and then we'll go from there. So it's a first 2, and since we have the first 2, we can actually do. So since this is an edge, we can do the page info object here, and we'll say has next page and the end cursor. So if you run this, again, so it will say this has the next page and this is the end cursor. So we can take the end cursor and then we can actually get to the next page. So you can then say first 2, and then you can say after the end cursor. And if you run the same query again, so this will make sure it will only have one element in it, and it'll say has next page is false, and the end cursor will be this object. And if you take this base 64 and see what this has, this will also have pretty much the primary key of the next object in there. So it will basically say, oh, 4 onwards, even though the object 4 doesn't exist. So that's where you have to use the has next page. So that's about edges in Graphql. So this way, implementing pagination on a relay-based server is like really easy.
Do the servers do query optimization?
It's entirely up to the server to do it. I mean, most good servers do query optimizations. Let me put it. And I have written my fair share of bad servers. Yeah, it's not mandated by the spec. So it's up to the server to do query optimization. But since we are using PostgreSQL as a part of this, most of the queries here would be pretty optimized.
Is that the actual query that's passed to the Postgres database down
Yep.
below?
Yep. So this is actually the actual query that gets passed down to the Postgres database. And yeah, so essentially this, if you can see, there is nothing happening on the PostgreSQL layer. PostgreSQL basically acts as a, 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 a GraphQL to a SQL query compiler. So you can actually run this query on this. So like, for example, you can do and I think you can just paste this query and it should work. Oh, sorry. I think there are some things that we need to, I don't have an editor in here. Let me try to find out if we can edit this. yeah, I think this is basically, let me just put this here because it's like a prepared statement. So everything else should just work. Um, let's see, I think this should be it. So let's see if this works. No. I, I might have messed this up, but let's see. Mhm. Yeah, somewhere it's getting messed up. I think it's because of uh, it's, I think its ID is to begin. Yeah, if I look at the prepared plan and then like replace the dollar these things with the actual values that are getting passed, I think it should work. I just need to convert them to begin and then send it. Actually, I think it needs it has a $1 and a $2. Uh, yeah, I can debug this and yeah, but this is the actual query that gets passed in, and that basically gets constructed out into JSON objects and just sent back to us. So it's actually pretty cool, and it's very, very performant. And the query is not that off. It's actually fairly simple. It just looks gnarly because it has these multiple levels of nesting, and it's doing the nesting on the Postgres side, but it's not that hard to construct or deconstruct, should I say.
That helped to mystify quite a bit.
Yeah. Cool. So if you have any other questions at all, or if you have any doubts with GraphQL and how this works and all that, I'd be happy to answer. I'm also on Slack, so feel free to mention me, and I'll try to do my best.
I guess you don't need a PhD in wizardry to use it.
No, it's actually fairly straightforward. It's fairly straightforward, and I feel this is much better than like REST-ish interfaces because they are very widely inconsistent. Yes, for server-side implementers, GraphQL is a pain, but so is actually a good REST interface. I mean, the problems will pretty much persist because I think the problems exist because of microservices and how they are architected, and not really because of the API specification. And I think as far as API specifications go, I think GraphQL is quite well documented.
My brain is full.
I wouldn't fault you.
It's a really good walkthrough, Vagmi. Thank you.
You're welcome. Thanks. Thanks, Rudy. Right. So thanks, folks.